Okay, level 3 says solve the equations, use a different method for each problem, use exact answers. Okay, so when we are solving problems like number 21, you look at this and you can go potion law. You could do completing the square, you could do quadratic formula. I'm going to do this one with quadratic formula. The reason I would pick quadratic formula or potion law if you prefer that is that there is a leading coefficient and it doesn't divide out nicely. And so when I see that, I use quadratic formula. I like it better. So I know this is A, and this is B, and this is C. Remember that B needs to keep its sign with it. So I go negative B. Well, a negative is a positive. Plus or minus B squared is 121. The square root of B squared is 121. Minus 4 times 6 times 22. All divided by 2A. So A is 6. So I've replaced all of the things that I need. So then I take this part right here and I put it in my calculator. Just everything that's under the square root. I don't include the square root symbol. So I go 121 minus 4 times 6 times 22. And I get negative 407. So I've got 11. Sorry, switched markers on me. 11 plus or minus the square root of 407 all over 12, which is fine as an answer, actually, because this doesn't simplify, so I can do that. If you had done potion low, you would probably have 11 twelfths plus or minus the square root of 407 over 144, and I would accept that as well. It's just that that would simplify or be equivalent to. Okay, on 22, we have a problem because here's our equal sign. And all of this stuff is over here, and we only know how to solve these very well when we either have 1x, or we can factor, or we can complete the square, and everything but 0 is on one side. And so I need to undo this so that I can get 0 on one side. So I'm going to subtract 4x. Sorry, I keep forgetting to switch which marker I'm using. Subtract 4x. And there is no 4x on this side or any x term, so I'm going to put it in the middle. And then to get rid of minus 9, I would add 9. I'm going to put that under its like term of plus 7. Okay, so I end up with x squared minus 4x. 7 plus 9 is 16, plus 16 equals 0. Now, if I can factor this, I would factor this. I can't factor this very well. If you can complete the square, you can complete the square. I think that's what I'm going to do on this one just because I haven't done it that way in any of the other problems yet, really. So I'd go, this would be an x minus 2 squared. And I know that because I divide that in half. It would be subtracting 2 on each side. 2 squared is 4. So I'd go plus 16 minus 4 plus 12 equals 0. And then I solve minus 12 on both sides. So I've got x minus 2 squared equals negative 12. To undo the squared, I would square root on both sides. So I would have x minus 2 equals positive or negative, the negative square root of 12. And I go, okay, I know that's not real, it's irrational, or it's imaginary, but I'm going to deal with that in a second. So I would get, add 2 and add 2. So I'd get x equals 2 plus or minus the square root of negative 12. Well, the square root of negative 12 is imaginary because it has a negative square root, so I would rewrite that as 2 plus or minus the square root of 12 times I. Now, if you're really good at math, you know that 12 is 4 times 3, and 4 is 2 times 2, which leaves these two 2's that can come out. So we could also write this as 2 plus or minus 2 square roots of 3 times I. And you may see that if there's a multiple choice option. Okay. Number 23 says solve the system. Well, they're both set equal to y, so this is actually pretty easy. We're just going to set the two y equals equal to each other. So I've got negative x squared plus 6 equals negative 3. So I'm going to try to get this x squared. There's only one x value anywhere in here, so I can get it alone. I'm going to minus 6 on both sides. I get negative x squared equals negative 9. They're both negative, so I'm going to divide by negative 1 on both sides. And I get x squared equals 9. And that's a pretty simple one, x equals 3 and negative 3. Now the problem is a system has to have an x and a y value. So we go, when x is 3, plug it in. Oh, look, y is also negative 3 there. And when x is negative 3, y is negative 3 there. So these would be the 2 points on the graph where they crossed. This one's a little bit more complicated, but again, they're both solved for y, so we just set them equal to one another. 2x squared plus 5x plus 7 equals negative 2x plus 10. Now I've just got an equation like the one above it. I just add 2x to get rid of minus 2x and subtract 10. Add 2x minus 10. So I've got 2x squared plus 7x minus 3 equals 0. So I can use quadratic formula. I could use Poisson-Low. I'm going to use quadratic formula. So negative 7 plus or minus the square root of 49 minus 4 times 2 times negative 3 all over 2 times 2. So I've got negative 7 plus or minus, so 4 times 2 is 8, 8 times 3 is 24, that would be negative minus a negative, so it would be 49 plus 24. So 49 plus 24 is 73 all over 4, and that would be fine. So then we plug that in. So this is x equals, so we have this nasty number, x equals negative 7 plus the square root of 73 over 4 is one of our answers. So we're going to go like this, get rid of the x equals, and put it inside of an ordered pair. When x is this, what is y? So this is a nasty number. We plug it back in, and we go negative 2 times negative 7 plus square root of 73 divided by 4. Plus 10. Well, that cancels. So now I've got negative 7 plus the square root of 73 over 2 plus 10 would be my y value. I can also do it for the other one. Negative 7 minus the square root of 73 over 4, comma, plug that in. This would just be a minus sign right here. So I've got negative 7 minus the square root of 73 over 2 plus 10. And I lost a negative there, didn't I? These would be positive. And this one would be negative. And that's fine. If you just leave it like that, I'm okay with that. It is ugly numbers. So as long as I know you know how to plug it in for y, you're good.